All right, ladies and gentlemen, today we are going to step up our fractions work a notch. We are going to add and subtract fractions with unlike denominators. And we're going to be answering the questions, why does it matter if the denominators are the same or if they're different? And then, great, they're different. Now what? Well, let's find out. Last time we were working on adding and subtracting fractions, we worked with things with the same denominators. And in this case, I am visually representing 1/5 plus 3/5. Whoops. And 1, 2, 3, 4. There we go. 1/5 plus 3/5 obviously equals 4/5. And if I wanted to, I could even put them together and compare it to a whole done up in fifths, and you could see very quickly that I'm telling you the truth. There it is, and sure enough, you can quickly see that 1/5 plus 3/5 is equivalent to 4/5. So let's shake things up a little. What if I wanted to add 2/6 plus 1/4? Well, what a lot of kids would try to do would be to try to just add 2/6 and 1/4. And then try to add everything straight across and end up with an answer of 3/10. Well, you can't do that. And let me take a quick second and show you exactly why you can't do that. You can see the value of the three fractions I just put together by making a bar. Let me show you what 3/10 looks like. So in the bottom, I've placed 3/10. And you can see that 1/6 plus 1/6 plus 1/4 is not at all equivalent to the 3/10 value on the bottom. In fact, the bar on top is almost twice the size of the 3/10 on the bottom. They can't possibly be equivalent. Lovely. Okay, so since that doesn't work, now what am I supposed to do? Well, there are steps for adding fractions that have different denominators. The first one is the obvious one. You're going to ask, so are these denominators like or unlike? And hey, if you're lucky, they'll be like, and you can just go ahead and add those bad boys together or subtract them. But as you get older or further advanced in math, you'll find more and more that they are unlike. So, if they're unlike, as they were in the problem before, what you got to do is find a common denominator. And you're going, great, how do I do that? You already know because you've done equivalent fractions already. Dig back in your memory. Remember that LCM, which stands for least common multiple thing? We've done this. What we've got to start with is finding the LCM for the two denominators. Earlier we were adding 2/6 plus 1/4, so that's what I'm going to work with. And if you remember, let's see, the multiples of 4, are, 4, 8, remember I'm counting by, 12, 16, well that's nice, and 20. I should probably do it. Now let's count by sixes. 6, 12, 18, hello, already found it. Here it is. I've got 12 here, and I've got 12, come on pen, 12 right here. So that means that I can make fractions that are equivalent to each other by using a denominator of 12. So that means I have to do a little bit of quick converting. Let's take our 1/4 here. 1/4, how many twelfths does that equal? Well, I have to ask myself, how do I get from 4 to 12 times what? Or I could also look at it as 12 divided by 4. Well, that would be 3. And remember, when I make equivalent fractions, if I do it to the bottom, I got to do it to the top. Why does that work? Well, because 3/3 is the same as 1, and any number times 1 equals that same number. So if 4 times 3 is 12, 1 times 3 is 3, and 1/4 is equivalent to 3/12. Okay, let's handle 6. We had 2/6, and I want to turn it to 12ths. How do I get from 6 to 12? Times 2. Do it to the bottom, got to do it to the top to make this 1. 2 times 2 is 4. Okay, so now, rather than 2/6 and 1/4, I now have 3/12 plus 4/12. And guess what? Whoop, that's not neat. The denominators are now the same. Woohoo! Which means, I can just go ahead and add those bad boys. So 3/12 plus 4/12, doesn't matter what order I put them in? No, I'm adding. Done. Now, if I end up with a number that can be simplified, that's my last step and I need to do that. As you can see, I've got 7/12. 7 is prime, so it can't be divided by anything. And 12 is not a multiple of 7, so this is already in lowest terms. It's been simplified, it's been reduced. My final answer is going to be 7/12. Now this time, let's check it with the models. So there we go, I pulled up the models, and you can count real quick and see that 1/6 plus 1/6 plus 1/4 actually is equivalent to 7/12, which is nowhere near 3/10. So let's practice a little bit. You've got the next two problems in your notebook. Let's start with the top one. Okay, we're going to do an addition this time, and this time we've got 3/4 plus 1/3. So step 1, check to see if the numerators are like or unlike. Yeah, they're different, they're unlike. You knew that was coming. This is a lesson about that. So step 2 is to get my denominators the same, which means, of course, I will need to find the least common multiple of 3 and 4. Well, that's not too bad. All right, let's count a little bit by threes. Let's do 3, 6, 9, 12, 15. Sounds good. All right, let's count by fours. 4, 8, 12. Hello. Again, we got 12, which isn't really surprising because 12 has a bunch of factors. So it tends to be kind of a favorite when we were doing things with fractions. Okay, so next step then is to make my conversions. 3/4 into 12s, and then 1/3 into 12s. Okay, how do I get from 4 to 12? Or, what's 12 divided by 4? 3. So if I do it to the bottom, got to do it to the top, because this is 1. 3 times 3 is 9. So now I'm dealing with 9/12, so not 3/4. Okay. And then okay, 12 divided by 3 is 4. Do it to the bottom, got to do it to the top. 3 times 4 is 12. 1 times 4 is 4. So there's my second fraction, good to go. Working in 12ths. So now my next step is to go ahead and add them together. We've got 9/12 plus 4/12. 9 plus 4 is 13, and we're leaving the denominator the same. All right, so now I've got the basic addition problem under control. I've got 13/12 for an answer, but here's my issue. That can be simplified because right now my numerator is bigger than my denominator, which means, that's right, improper fraction. So let's take care of that problem. 12 goes into 13 one time. 1 times 12 is 12. That gives me 1 and 1/12. There's my whole number. 1 is, well, it's 1, so there's no point in even trying to simplify any further. 1 and 1/12 is my final answer. Woohoo! Okay, so let's hit another example in your notebook. This is actually the third one down, but I wanted to do a subtraction with you before I let you go. So we'll leave the other two for your quiz, and let's work this one. All right, step 1. Are the denominators like or unlike? Well, obviously, they're unlike. So, time for a little LCM action. Let's count by 3s and 6s, and this one won't take long because you're going to see something real quick. Count by 3s. 3, 6. Well, duh. I'm already done. I only have to change one of these fractions because 6 is a multiple of 3. So 6 can actually be left alone. It's the thirds I got to change. So let's change thirds to 6. 6 divided by 3 is 2. Do it to the bottom, do it to the top. No, really. 1 times 2 is 2. So rather than dealing with 1/3, get this out of here, we're going to deal with 2/6. Oh, why that's not cooperating. There we go. Okay, and in this case, 5/6 take away 2/6. 5 minus 2 is 3. Leave the denominator alone, and I have 3/6 for my answer. But wait, there's more. 3/6 can be simplified, and if you're quick with this kind of stuff, you just went, oh, well, 3 is half of 6. Come on, Clark, this is a half. And you would be exactly right. Not so bad, just looks kind of crazy. So today we have learned, why does it matter if the denominators are the same or if they're different? Fractions aren't fruit salad, people. You can't shove apples and oranges together. It just doesn't work. And then, great, they're different. Now what? We follow the steps. We check to see if the denominators are different. Great, they're different. Now what? We find a common denominator. We make our conversion so that we have equivalent fractions. We add or subtract those bad boys, and then we simplify them. Easy peasy, we got this. It was kind of long today. Thanks for hanging in there. Have an awesome afternoon.